Welcome back to the channel. So last time we finished up this crankshaft and got it installed here. It turns nice and free. I want to make sure that there's no binding in there, that it turns good. Least amount of friction that you can get in binding, make it easier to start and run. So if it's too tight, it won't want to start and run. So we got that good and cut the keyways in the crankshaft. Then we made the bushing with the broach and then cut the tapered keyway into the flywheels. So next thing we need to do is make the keys for this. So like I mentioned in the last video, there are dimensions in the plans for these keys, which I think I can follow, and I think they're going to fit. But to find out for sure, I took some gauge pins here just to get a rough idea of where we was. So I put a gauge pin in here and just turned it around and see where it would just start to slip in there at the end. So that one just barely, if I push pressure down on it, it just barely catches and wants to start in there. And this is a 94 thousandths gauge pin, and then the key at the tallest point is 3/32 or 94 thousandths. So, and that's how deep we're supposed to be on the deepest end, is 3/32. It was just a little bit shallower than that with our broach. So I did do just a little bit of touch of filing in there to get that to where it's 94 thousandths on both of them on the outside. Then I took some gauge pins just to check what this inside is, but that should work. We can just follow the plans. So to make that out of, I've got just a scrap piece of steel here. It's a little bit too thick, and then it's been just rough bandsawed out. So we'll get this in the milling machine and get this flat on, probably just go ahead and do both edges there. And then we need to thin this down by a little bit. It's a little bit too wide. And then we'll do some layout on here and get us two pieces kind of rough cut out that we can set up in the milling machine to mill that taper onto. And then to set that up with the taper, I'll use the same, because our taper is 1/8 of an inch per 12 inches. So I'll use a 12-inch steel rule and then some blocks on both sides, and then put a 125 gauge block under one end of the steel rule and line this up with that. And then we can machine that taper in there and then get it to dimension. And then there'll probably be some hand fitting, at least that's the way it was on the Thorn Boy engine. Leave it just a touch big, and then we can take a Sharpie and Sharpie up the top, kind of tap it in there and then pull it out and see where the high spots are, and then we'll just fit each keyway to the flywheel and to the crank. Make sure that's a good tight fit. So I'll get this set up and we'll start machining on it. Okay, so I got the keys finished up. They're extremely tiny and they are a little bit difficult to make. An idea of the size there of them. So I took that piece of metal that we started with and then squared it up in the milling machine, and then used these. You've ever seen these before? They're called hold downs. These are a Lufkin, a 902B, and if you look at the end of it, it's probably hard to tell on camera, but this is not perfectly square. So it's good to hold thin stock in a vise. You can put your stock in between there, and when you tighten the vise jaws up, it actually pitches them like this and pushes down. Show you here on the end. It actually tilts them this way and then actually pushes down on the material. So it allows you to hold really thin material, as long as it's thicker than this, or it could be thinner than this, but you can't machine all the way out to the edge because you would hit your clamp here. So our piece was a little bit thicker than what this is, so that allowed me to clamp it in the vise and then thin it down. It was a little bit too wide, so I thinned it down to the 3/32 that we need to fit in the keyway groove here. These, I don't use them all the time, but they're really handy in certain situations like that. So once it was thinned down, I cut a piece off that was the overall height that I needed here, and then cut 2 pieces out of it the length that I needed, and then I set it up in the milling machine at our 1/8 of an inch per 12 inches of taper using the steel rule. I'll put a picture in here of what that looked like. So then I machined this taper, and I know how far to machine it down, what our height needs to be here in the back, but I did leave it just a little bit tall. The easiest way that I've found on these is to make them, and you don't want to go too small, because if you go too small and it goes all the way in and doesn't tighten up, it's no good. So leave it a little bit tall, and then I'll take Sharpie and Sharpie this entire top surface here, and then lightly with a brass hammer tap it in and then pull it back out. And then to pull it back out, the way I was doing it was kind of set it out here on the end and then put it in there and just snug it up a little bit, and then I would actually just tap on the flywheel and knock the flywheel back, and that would loosen it up. But if you get it in there all the way, I did for the Farm Boy, I did make this just a little wedge here. It's a radius here on the back and the front, and then you can get that in there and just tap it with a hammer, and then that'll kind of pop that loose. A pure triangle didn't work as good as a little bit of a, it seemed like a little bit of a radius there on the back kind of worked the best. But you can tap that in, and then this radius on the back side here kind of keeps it from damaging your flywheel there. But then you can this in here. So once that's all the way in, then this will go in there like that, and then wedge that out. So then you can set the flywheel in or out where it needs to be, and then we'll tap that in. Don't think there's a dimension in the plans for where this is, but I did want to make sure that it was in far enough that if I decide to put a pulley on the outside of this, I can. So we'll just take a brass hammer and tap that in. And you want to leave a little bit of a space between the flywheel and the end of the key so that you got somewhere to get your wedge in there to knock it back out with. So that does that side. Same thing on this side. And then this flywheel will actually be a little bit farther out because we have to fit a gear in here and the spool that controls the push rod, the latching mechanism. So this one will be a little bit farther out. So we'll just tap this in there. So you want to make sure that they're good and tight, that there's no play in between them, and make sure everything still turns good. And we got a little bit of, still got a little bit of in play on the crankshaft, so everything looks good there. So that's going to finish up the keys for now. We won't tap them in there completely tight until we're completely on final assembly. We can tap them in there a little bit more, but that's enough to hold everything in position for now. So next thing we need to start on is the connecting rod. So we can connect it from here on up to there. So this comes in the kit as just a rough casting. I'm pretty sure that it's a brass. It could be bronze, but I'm pretty sure that it's brass casting. So the first thing we need to do is clean this rough casting up to the overall width that we need here on the big end. And we'll go ahead and clean it up for the width that we need on the small end. And then I'll probably go in here and touch this up here and get a good flat surface there for our bolts that we'll eventually put in here. Once this is machined though on all the sides, then I found the easiest way is to go ahead and drill and tap these holes here for the connecting rod bolts, so we can drill through with the tap drill size, and then we can come back with the clearance drill and drill halfway down, and then we'll go ahead and tap this. So then once we cut this apart, then we know that these two pieces are perfectly lined back up with each other with these bolts. So once that's in there, then we can go ahead and cut this apart, and then we'll bolt this back together. Then we can put the hole. We may have to machine some off depending on how high this cap is and what the overall dimension is here after we cut it apart. We may have to machine a little bit off of both sides, but once we get that set, we will bolt it back together. Then we can drill and then bore this hole out here for the big end. And then if we can, in the same operation, but you definitely want this hole to be parallel to this hole. You don't want it off kilter. We'll get this hole in the small end, and then we'll have a dimension for the connecting rod length between this big end here to the small end. So we'll get that hole drilled in there, and then I think that'll finish up the connecting rod. So we'll start, like I said, by getting the rough casting machine down to the overall width. Okay, so that finishes up the connecting rod. So we set it up in there, and then first thing I did was machine these sides here down flat to the overall width that we needed to fit the journal here on the crankshaft. Then I set it up, and then I drilled all the way through for the tap drill size for this 440, and then drilled about halfway through for the clearance size for these bolts that I made. And after that, then I machined this down to the overall height that it needed to be, and machined this step in here. It gets a step like the main journal caps have that helps locate it. So you can see the step there. So I machined this out on the inside, and then took the main cap, flipped it over, and then machined off the sides here so that it would fit down in there. Then I also counterbored, or took an end mill and run it into here and give some clearance, and clean this up here and give clearance for the screws, and then cleaned this up on the end, and then went ahead and drilled that through so it could be tapped for the grease cup. Then machined down this end here to the overall width. Got a little bit thin here. I machined a little bit too much on the one side, but it will still work. And then after that, set it up and drilled and reamed this 5/16 to fit on the crankshaft here, and then drilled and reamed this 3/16 here for our piston pin. Then I just sort of cleaned up the casting everywhere. Probably will sandblast this before the final assembly, just to sort of blend everything back in and make it all look the same. And then I tapped this here for our grease cup. So that's gonna, I have test fitted on here, but we'll go ahead and get the piston and the pin made, and then we can put everything together, make sure everything is gonna work. It looks like it is centered up good in the cylinder and running good and straight, and then good and true, and it's good and tight on the crankshaft here. So that's going to do it for this episode. Come back next time and we will start on the piston. So we'll get the piston and piston pin made, and then get all this assembled and make sure it's all going to run good. Thanks for watching.